So this video is all about percent yield. So percent yield is used by chemists to figure out how good a chemical reaction really is. Let's face it, not everything goes as planned. So sometimes chemical reactions don't go all the way to 100%. So what happens here is that a percent yield is a way for a chemist to report out how effective a chemical reaction really is. So the percent yield is very easy to calculate. You take the actual yield divided by the theoretical yield and multiply it by 100. Well, so you're probably wondering, what do those terms mean? Well, the actual yield, just like it sounds, is the amount of substance that you obtain when you do a chemical reaction. So the actual yield is what you actually get in the reaction, and it's what you measure in the lab. The theoretical yield is the predicted mass of the product that you will get based on the stoichiometry of the balanced equation. So essentially, the theoretical yield you figure out by using the mole calculations, the mole ratio calculations I've been working that you've learned in class. Okay, so let's take a look at a sample problem. So here's a chemical reaction where aluminum hydroxide reacts with hydrochloric acid. All right, so the first one, we want to find out the theoretical yield of aluminum chloride if we react 1.25 grams of aluminum hydroxide. So if we're looking for theoretical yield, that means use the stoichiometric relationship, set up the mole ratio problem, and calculate your answer. So we start with what's given in the problem. Grams of aluminum hydroxide, I'm just going to abbreviate it ALOH. Change that to moles. 1 mole ALOH for every, notice I put the molar masses in just to make it a little easier. So the molar mass of aluminum hydroxide is 78.01 grams. Okay, we need the mole ratio because what we're trying to find out is the theoretical yield of aluminum chloride. Well, it looks like a 1-to-1 mole ratio. I'm going to go ahead and write it in here. 1 mole of aluminum chloride for every 1 mole of aluminum hydroxide. All right. Final step, we're going to change from grams to moles of the aluminum chloride. Aluminum chloride has a molar mass of 133.4 grams, and that's the mass of every mole. So we're going to put 1 mole AlCl3 in the denominator, and ta-da! Oh, it didn't cancel. I knew that was going to happen. Oh, here it is. There we go. There's our theoretical yield. Round it to 3 significant figures, and we have it. So, because our starting number is 1.25, so we have to have 3 significant figures. I'm going to abbreviate that TY for theoretical yield. 2.14 grams. Okay. So we know that we're supposed to get 2.14 grams. That's our theoretical yield. Now let's see what it says in step 2. If we actually do this lab and we get 1.975 grams, that would be our actual yield when this reaction was done in the lab. So to find percent yield, all we need to do is we take the actual yield, 1.975 grams, divided by the theoretical yield we just figured out, 2.14 grams, multiplied by 100, and there it is. Wow, that's pretty good. 92.3% yield. That's a really good yield. Chemical reactions, let's just face it, the yield is not usually that high. If you get above 50% in real life, you're doing all right, especially when you take organic chemistry. All right, so there you go. It's not that hard. So there's our percent yield for the reaction. There's another problem at the bottom. Give it a try. Part B is a little bit of a challenge problem. Let's see if you can get that. And submit your answers. We will check them in class.